All right, we are looking at chapter 18 here. Chapter 18 is all about equilibrium. Big chapter, huge chapter in chemistry. Lots of information here. You definitely want to focus on this chapter and make sure you understand everything about equilibrium. Equilibrium will always occur anytime you have a reversible reaction. Remember, you'll have an arrow going one way and an arrow going the other way, and that means the reactants are turning into products, but also products are turning back into reactants. Okay? Uh, to what extent? It depends on the reaction. Sometimes a reaction is going to have, at equilibrium, lots of products and very little reactants, or lots of reactants and very little product, or almost the same of both. Okay? And so when you've reached equilibrium, that means the forward reaction is happening at the same rate as the reverse reaction. It does not mean that you have equal quantities of reactants and products. That's not what it means. Equilibrium is talking about the reaction rates comparing forward and reverse. Those two are eventually going to be equal. And when they are equal, then the concentrations of your products and reactants are not going to change significantly once you've reached equilibrium. Remember, there is a value that we use called the equilibrium constant, and that is very helpful. Remember, it is the concentration of your products. Let's say you've got products C and D over the concentration of your reactants. Let's say you've got A and B. And if you've got coefficients, like let's say you've got this type of reaction, I'm just making it up, just general. Remember, these coefficients right here become the powers on these concentrations up here. So this would be cubed, that's still 1. This A would have a 2 on it, B would have a 1, and this would be your equilibrium constant expression. It is always products over reactants. If this K is very large, it means you've got lots of products, little reactants. If this K is really small, it means you've got mostly reactants and very little products. If that K is close to 1, it means you have close to being the same concentrations of products and reactants. So that single number tells you a lot about the equilibrium position, where it's at once it's reached equilibrium, and the relative quantities of your products and reactants. And then you have to know about Le Chatelier's principle. Remember, once you've reached equilibrium, and then if you go and do something to mess up that equilibrium position, you provide a stress, it's called. If you change the pressure, if you change the concentration, that reaction, that reversible reaction, is going to shift in order to get back to equilibrium. A change in pressure and a change in concentration will always get this reaction back to the same K value. But a change in temperature, now it's going to get to a new K value. It's going to get to an equilibrium position, but it's going to get to a different K value. All right? So you need to look back and figure out, when you change pressure, which direction is the reversible reaction going to shift? When you change concentration, how will it shift? When you change temperature, how will it shift? You must know those three things. Okay? The common ion effect is simply also applying the Chatelier's principle. That just means if you have a reaction and it has a certain ion, a certain chemical in there, if you add more, if you add something that's common, you are going to change the concentration. If that concentration changes, then it's going to shift one way or the other. Okay? Remember, if it shifts one way, maybe you have a precipitate. Maybe one of your products is actually a solid, and if it's shifting in that direction, you're going to make more and more of that solid. Okay? Okay, let's look at a couple problems here. It says calculate the equilibrium constants for the following hypothetical reactions. Assume all components of the reactions are gaseous. So they give you this right here, general reaction. It says at equilibrium, the concentration is this, and C and D are both that. They give you the concentrations of your reactant and your two products, and you now know that the K expression is simply products over reactants. And as a result, notice the coefficients here are all 1, so that's not a problem. The coefficients are all 1. You're just going to plug in these values. A is given, C and D are both given. Plug in those values and evaluate. There are no units on the K expression, so just get the value there and write down the value for K. All right. Same thing here. This time you have two products, two reactants. You are given the concentrations for A and B at equilibrium. It's important that this is at equilibrium. You only find the K value at equilibrium, using the concentrations at equilibrium. And then C and D are both that, so you plug those in and evaluate. C as well, at equilibrium. A and B are given to you. C is given to you. Just be aware that there's a coefficient on C. So that concentration for C is going to be squared, and that is in your numerator. C is going to be the concentration of C squared over the concentration of A and B. And that is going to be your K value. Okay? Same thing here. You're given the concentration of A, you're given the concentration of C, you're given the concentration of D. Just be aware of the coefficients for A and C. That's going to affect how you evaluate that in the K expression. This one is the same thing. They're giving you the concentrations at equilibrium. And this one as well. Be aware of the coefficients. They're giving you the concentration of A, B, and C. You must do these problems. Even if you look at this and say, no problem, I got it. You have to figure out if you can do this on your own. Instead of just listening to me talk about it and listening to me do them, you've got to make sure you're pushing your buttons, writing, forcing yourself to think through these problems, and catching any mistakes that you'd make. You want to make them now and not on the final exam. So take the time and work through these problems and check all of your answers here below, as well as look back at the interactive reader. Force yourself to read through those again. Check the Schoology problems, quiz problems, and ask questions. Okay?